and welcome to this legacy video where you will learn about calorimetry. First, you'll need to know some background information. Calorimetry, in the most basic sense, is a measure of heat. Heat energy can be given out or taken in from the surroundings during chemical reaction. The amount of energy transferred can be measured, which is what calorimetry is. In 1761, Joseph Black introduced the idea of latent heat, which led to the creation of the first ice calorimeters. In 1780, Antoine Lavoisier used the heat from the guinea pig's respiration to melt snow surrounding his apparatus, showing that respiratory gas exchange is combustion, similar to candle burning. From this discovery, Lavoisier dubbed his apparatus as a calorimeter, and one of his first ice calorimeters was used in the winter of 1722 by Lavoisier and Pierre-Simon Laplace, which relied on the heat required to melt ice water to measure the heat released from chemical reactions. Now we need to know what a calorimeter does and how it works. For calorimetry, you'll need a caliometer. A caliometer is a very basic concept. It consists of a heat bath, which is something that you'll need to know specifically changes over time, such as water. Inside the heat bath, you will have your chemical system, of which you want to measure the calorimetry with a temperature measuring device. Most caliometers have a heat insulator outside of the heat bath to reduce the amount of heat lost to the environment. These can be made of styrofoam or even steel. The goal is to make the heat transfer between the chemical solution and the heat bath as pure as possible. With a measuring device, you can find the temperature change and then calculate the exact energy change. Now that we know the basics of calorimetry, we need to understand what a calorie is. A calorie is the energy needed to raise the temperature of 1 gram of water through 1 degree Celsius. A calorie is like a unit of measurement, and you usually see it on food. But it actually doesn't measure how much exercise you get after eating the food, but it measures the amount of energy the food contains. Now, you're not listening to this video because you actually want to learn about calorimetry, but actually because you want to know how to do the calculations. And to that, I say Q equals MCAT. In the equation Q equals MCAT, M is equal to the mass of substance, C is equal to the heat capacity, and T is equal to the temperature change. Now let's try this on an example question. When 1 gram of fructose, a sugar commonly found in fruits, is burned in oxygen in a bomb calorimeter, the temperature of the calorimeter increases by 1.58 degrees Celsius. If the heat capacity of the calorimeter and its contents is 9.90 kilojoules per degree Celsius, what is the Q for this combustion? In this problem, we are going to substitute the mass with 1.1 grams. Also in the question, the temperature change is going to be 1.58 degrees Celsius. Also C, which is the specific heat, is going to be 9.90 kilojoules per degree Celsius. With this, we could plug all these values into the equation of Q equals MCAT. When you plug in all these values into Q equals MCAT, we get the value of 15.642 kilojoules.